a chance, I take it slow. And I know I just can't leave these things behind. Trying to feel satisfied in my world. I am looking for
Should be good. Got my regular mic. Everyone should be able to hear me. In Discord, we're good. Let's switch to live. And there we go. So everyone tuned into my share.
Yep.
Cool. So this one is not really an ad lib me. This is all recorded, me talking, ready to go. It's mostly visuals, but it's mostly me talking. So if you have questions, throw them out. I'll pause it for the crew in here. We can ask relevant questions, but mostly we're going to let it go towards the end. And at the end, we'll have, I'm sure, a host of questions, and we can go through most of the concepts. Everybody cool?
Sounds great.
All right, here we go. So before we get started with this theory, presentation, understanding, and explanation, let's, be clearly equate it to the Glober equivalent, right? So when a Glober says, hey, I know what the stars are, where they are, what they're made of through stellar spectroscopy,
you are muted.
where they are through the infinite vacuum of distance, because the light years from the light that we can see, because light travels forever, it doesn't attenuate, right? That level of scientific verification.
You were muted.
And understanding.
Now you're not. Wait, are you playing something? I just see like a bunch of pictures of toroids.
That's where we're going to be living today, right? Like, so
I hear you talking, but I don't see or hear anything. Like, are you playing something?
Yeah,
Oh,
I can hear it. Sorry, I can hear it. It's just very low.
Oh, my bad, dude. I had it muted. I'm sorry. Because since there's nothing moving. Okay, I misunderstood what was going on. My bad, man. Sorry.
So before we get started with this theory, presentation, understanding, and explanation, let's, be clearly equate it to the Glober equivalent, right? So when a Glober says, hey, I know what the stars are, where they are, what they're made of through stellar spectroscopy, how far away they are through the infinite vacuum of distance, because the light years from the light that we can see, because light travels forever, it doesn't attenuate, right? That level of scientific verification and understanding, that's where we're going to be living today, right? Like, so from the flat earth perspective, this is going to be the comparative equivalent scientifically researched response to something like that, right? Because they have all the answers to the things that they think they know, and one answer requires explanations from the other, and they go down this, ever expanding road with crazier and crazier explanations. But so this is the equivalent flat earth explanation and understanding, and let's keep it on par with that throughout the presentation if we could. All right, so let's get started. All right, we're going to be taking another look at star trails and sky optics today, but first we're going to go back over what we already know. We're going to present a very efficient, concise presentation on what we know so far and where we're at, just so we can all keep on the same page of, the cause and effect and things like perspective, rotation, counter rotation, the effects on motion, all the things we discussed before. We want to keep them fresh in our mind because we're going to be adding one final element that kind of takes from all the other elements at the end. And that will explain, the difference between where we see a star and where the star actually is in the flat Earth model. If we recall, the first principle was the rotation and counter rotation explained by just the perspective and relative motion, right? We had one actual center of rotation. We had the apparent motion of that rotation changing depending on where and which direction you looked, where you were on the Earth and which direction you were looking in. The motion never changed, but your perspective induced the motion to appear to move counter, right? Everyone remembers that. So just a quick thought on motion and perspective, right? We only have one source of motion, but our perspective makes it look like more, right? So if we have motion like this, and you're in the north, you see that the stars are rotating one way, right? Everything goes together synchronously. If you go south, however, and look from the opposing viewpoint, if you turn around and look the other way, then the same motion looks kind of converse, right? It looks the opposite. It looks to rotate the other way. See how that works? So in the same rotation, same motion, depending on where you're looking from, will make it move one way or the other. Simple explanation. Just going back to P-Brain's video here about rotation and counter-rotation, and perspective being the root cause. I find it helpful to go through each phenomenon and its effect, and then to make sure we know what is causing each effect, so that we don't inadvertently loop other causes to other effects. So we have the counterclockwise rotation in the north appearing to rotate clockwise in the south as its counter. Again, run one rotation. Once you move in the south and look to the south, you see the counter rotation. The toilet paper tube rotating in one direction but appearing to rotate in either depending on which side you look is the best example of this uniform motion that we can ever use. Right? Perspective alone will show you this rotation moving both ways if you look in one direction or in the other. That's the simplest way to put it, and it's the best explanation for the counter rotation that we see in the south. So again, just to remind everyone, we have the corpuscular rays of the sun converging behind you on the opposing horizon to show you that you see in a sphere, that your vision will wrap light around you in this fashion. So that means that your perspective over the great distance will put things that aren't converging in a convergence point, like the end of the rays of the sun. They're not actually converging around only you, they're going out in perpetuity in both models, right? But in your model, the perspective puts those rays around you, even though apparently to you they're parallel, right? And we kind of covered this a little bit with the first one, but it is a separate thing, and I do want to make sure we keep the observed effect and the mechanism separate from each effect. For each effect, we'll keep the mechanism. If it's more than one, we'll write it, but we'll have a specified mechanism for each observed effect that we deal with. So the second one would be convergence and counterconvergence, meaning from the sun, if you're looking from the opposing horizon, when the light beams appear to converge on it, we call that the convergence point. And then when they extend past your head over behind you and converge on the opposing horizon, that's the counterconvergence point, right? The place where they're not really converging there, but if you didn't know that, you would expect to see a sun right where the beams converge, right? So the mechanism that we had for that, which is the optical limit of your curved visual space and sufficient distance, right? So if you understand that what you see is just the curved visual limit of your space, if you have like an understanding that you can see about 59 miles into the sky in any direction, creating a little sphere of your celestial horizon that moves with you wherever you are, just governing the limit of your visual space. And you'll notice that at the edges of the space that you can see, your vision will put it into a sphere, meaning that on each pole, what you see will appear to converge. Now, again, personal dome, nice azimuthal grid, a nice stereographical coordinate transform in Stellarium to let you know that the Walter Bisland's model is valid, because Stellarium uses that very view. That's where I got that footage. I went into the coordinate program, changed one button, and it instantly shrank to this personal dome. So again, the coordinate transforms are all relative. All frames are relative, meaning in any coordinate system, anything is valid. So easily transform back to this one. So now we're going to show. All right, and now on to the new. Right now on to the final mechanism, which we will explain very differently than we ever have, but will encompass all of the aspects of how the flat Earth kind of engine works. So previously, we used to use Walter Bisland's model to show celestial phenomenon with the personal dome. We're still going to do that. That still totally works. It's very effective. It just puts a very poor star location in for us. So the way that the stars appear in reality in that model is absolutely incorrect. It's just the globe model wrapped around the flat plane, which is fine to use for a tool map, but I always maintain that the lines never connected to the position of the real stars, because those stars had no bearing on the placement of the real stars. The model was only ever meant to show the relative position and the latitude dependency to each observer, which it was really effective at doing. What we need to know, and what the community needs to know, and what everyone needs to understand, is all of those things, plus where the stars actually are in their sky and why they're seeing them where they are. And that's what we're going to figure out today. So let's check this out first, just so we remember where we were coming from. Now, again, personal dome, nice azimuthal grid, a nice stereographical coordinate transform in Stellarium to let you know that, the Walter Bisland's model is valid, because Stellarium uses that very view. That's where I got that footage. I went into the coordinate latitude dependent. If we start in the north and we move our observer, say, halfway to the equator, we see that Polaris and the center point of rotation dips to 45 degrees. That's exactly what you would see when you map out elevation angles to Polaris. 39.59, right? If you're under at zenith where we started. And then if you go, so if you take a look, it's spinning, counterclockwise in the north. As they rotate, they rise and set. Super easy. We're going to move our observer back over to the equator a little bit. There we go. And now you can see it dips to almost where you can't see Polaris, which is what we started with the equatorial star trails. You can't really see either source of rotation, but they rotate around you like this. Super easy. Can't see anything else. Latitude dependent. So you can move this guy all the way around at this latitude, and his position of the poles will not change, right? That's the same for flat and for globe. Absolutely. And it definitely works in the north. So anywhere in the north is equal for the latitude. You can move this around everywhere, and everyone sees this, right? So if we go back to the equator, we move it past the equator, we start to see this optical convergence point that Pre-Brain pointed out, the anti-rotation sort of pop out. And if we rotate it around, you can see that there's anti-rotation there, and as the stars rotate clockwise, that rotates counterclockwise. Super easy, optical convergence point, latitude dependent. You only see it in the south because the radius of the sphere that you can see is 39.59. So we're going to spend a small bit of time on the importance of coordinate systems, coordinate system transforms, transposition, things like that. This is one of their biggest tricks that they use against us, and it's one of the more convincing lies that we get told. So the format in which data gets presented to you has a huge effect on how you interpret that data, right? That's just a fact. So when they give you Stellarium and they show you, how the stars move around you, and they say there's a celestial sphere, all those things are evidential towards the shape of the world, but on purpose have been presented to you with spherical coordinate systems with absolute certainty, right? So let's just take a moment real quick and look at Stellarium, see what we're dealing with, and see how easy it is to transform all of the data instantly into a completely different coordinate set with the same value. So it starts off in perspective, right? Right above you, you move around, all the stars move. You can pop to stereographic, pops it out a little bit to the side. Now you see everything is a circle depending on how far you look. Okay, let's go back to this. Oh, now we got fisheye. What's that mean? Well, the poles pop out at the other end. This is all the same data. It's all the same coordinates, statistically equivalent. Everything in here is exactly the same. Orthographic, one of my favorites, right? This is what Walter Bisland's model does. Plops this orthographic format data translation of the sky on a flat plane, lets you move it around and manipulate it. Then claims, haha, stupid flurf, light doesn't bend that way. Well, coordinate system transforms doesn't bend light, right? It just shows you a different orientation of the data while keeping everything statistically relevant. It keeps the distance between the stars the same. It keeps, everything the same. Equal area is another one. Not one of my favorites. That one's not so useful. This one goes into Hammer Atoff, a little bit wider. You can see the poles at the other side. And oh, look, it comes back down again. We got sinusoidal, which is a little bit of a triangle. Again, kind of a troll. Any coordinate system that we use is equal to the other one, right? Mercator projection. Pay attention to the poles here. What happens at the poles? Oh, it splays them out to the side and then comes right back around. That's what the Mercator map does. That's their excuse for Google Earth when you try to go to either pole, how you can't. They say, well, we use the Mercator projection and the translation of the coordinate system data. That's just a side effect, right? That's what they say. Nonsense. Miller cylindrical. Again, watch the poles, watch the data. This is good for the middle and the band of the tropics, but not for the poles. Final one is cylindrical, right? All the poles stay at the top. All the data stays the same. Most people use this one and never even look at any of the others. Now, again, they're in here because they are all equally the same. We're going to go over that a little bit, and then we'll move on. It's also super relevant to what we're going to talk about next, which is coordinate systems. Right. So coordinate systems. Essentially, we're going to talk how they took the azimuthal transformation and from Cartesian coordinates to put it into a cylindrical transformation with a ceiling of infinite height. Right. So this is how they mapped the so-called celestial sphere. They took a whole collection of personal azimuth elevation angles and altitude, and they combined them from all over the world, depending which they noticed vary on latitude, and then mapped out a coordinate system with all the stars and when everyone would see them. It seems super easy when you think about it. Right, so all points on a sphere around the origin have the same distance and celestial coordinates, and they all look like altitude d. Right, so they take a flat 2D structure, can be drawn like an A projection map as an angle around the center with an altitude as a distance from said center. Right, so by doing so, they transformed into an infinitely high cylinder. So let's see how this works with Stellarium. This is the default Stellarium viewing mode. I've just added the azimuthal grid, and we're just at somewhere in the eastern United States. We're looking at a sky, and it's slowly rotating above us. We zoom out. This is what we see in perspective mode. This is meant to imitate close to reality as we can get. Now, if we switch the viewing mode to something called orthographic, we notice the orthographic view actually resembles very much a personal azimuthal grid, literally mapped to the observer. And as you see, with this viewing mode, if we go around the world, we can see this exactly maps to it. If we change it up a bit and put on the other grid, so we go from azimuthal grid to equatorial grid, we now see that this sphere moves with us as we go, and this exactly mirrors Walter Bislin's model, right? So here's the southern rotation as we go south, as it slowly rotates around this way, and we're going to go, actually move this map over here, you can see what we're talking about. We're going to go over here to the South Africa, and look, there's the southern celestial pole right over there, just like is imitated and emulated in Walter Bislin's wonderful model. We go back to the north, and we don't see the South Pole. We see everything rotating around Polaris. Now, if we change this viewing mode back to what we had before, let's see, perspective, then it just pops right back out, and there we go. So coordinate system transforms are seamless. It can do this so quickly because they are mathematically identical. It's simply a coordinate system transfer that they've extrapolated to get the actual coordinate and mapping of the celestial sphere. Now we can see them side by side. We have Walter Bislin's model with a user personal azimuthal grid that follows the observer compared to the actual orthographic view of a 3D mapped celestial sphere, which moves around the observer as well. So as you can see, they are identical. If we move this, let's see, to a different observer latitude, that would be this way. Let's go about here, and then we can do the same within our Stellarium if I can find the map wherever I put it. Let's do this. There's the map. And we'll go over here, and we'll put it right there. So there we have the exact equal, right? The exact equal observation right here as time progresses. So we have the this is why I keep invoking Stellarium as a backing for the azimuthal grid, because it exactly is a method that's used all over for specific user and observer based measurements and comparisons. We can even go to the South Pole here. If I push this a little bit over here, we go back up to Stellarium and we move it, say, to Australia, and then we go back, and then we can see we actually have the same southward facing pole rotating just like Walter Bislin's model shows as well.
By
so
latitude.
This is why I like using this model.
Latitude dependent.
I want to talk about this meme from our favorite place, FlatEarth.ws, of the worst memes ever. This is trying to attempt to make fun of the linear relationship of Polaris's elevation angle to latitude in the northern hemisphere, while simultaneously saying that on the globe it's correct because they've pushed it out to infinity, meaning it's the same and right everywhere. It's just a mathematical cop-out to the same problem that is no solution whatsoever, while trying to deny the linear relationship of perspective on flat Earth, meaning they have to deny things like, say, streetlights, right? As you go away from something far enough, it decreases on your horizon, and they derived the globe model from this analysis. They actually determined that elevation angles to Polaris start at 3959 when you're directly under it, and then linear decrease from there. The whole globe model is built on this theory, actually, because that's the radius value that determines every other finite testable aspect of the globe model. The linear relationship of a latitude and elevation angle to Polaris in the northern hemisphere is a vital fact of the globe model. So for them to deny that relationship exists, first of all, is silly and asinine, and then to not say that it applies elsewhere in things like everyday perspective and the decrease in height of setting Street lights, you would think, what, the street lights are setting? No, they're obviously decreasing on my horizon and matching, elevation angle as we drive away. So same principle, very clear. Just wanted to touch it up. All right, now to go on to the final mechanism, which we will explain very differently than we ever have, but will encompass all of the aspects of how the flat Earth kind of engine works. So previously, we used to use Walter Bizzard or standing model. Everybody on polar stars, sky optics. We're gonna refine our previous model. We're gonna add to it. We're gonna make sure that we know where the stars are in relation to where we're seeing them. But to do so, we're gonna need a quick refresher, and that refresher is gonna be on some of my favorite concepts and some of the more relevant pieces of it. So the primer fields put forth a new understanding of magnetic fields in a double bowl magnet form. So they took the previous iteration where everything was one field and worked within a singular field and expanded it to the actuality of two, top and bottom magnetic fields. In other words, we don't live in a single toroidal field, we live in a double toroidal field. So this particular concept is super relevant and actually plays an integral role in the last part of our Southern Star Trail analysis. So we're going to quickly review what was put forth there and then tie it back into what we're talking about. You can see this is where he notes that they switch the polarity.
So as you can see, all the particles within the magnetic bowl are drawn to the flip ring, where they then enter the area under the confinement dome. Notice how at the flip ring, the balls flip magnetic orientation. That is why I call it the flip ring, because it flips the magnetic orientation of the matter passing through it.
So that's pretty much the crux of what we're going to use from this, but you should also take a look at this whole video. He does great work on, magnetic field theory without even knowing it. How he understands that there's an expulsion zone. He applies that to the sky and does, quasars and the nonsense they give us to look at there, but he deciphers it because they used real physics concepts. Also, just to be clear, while we're talking about things like magnetism and field and positive and negative, let's just be super clear for those who prefer an etheric framework over atomism that, there's no such thing as positive and negative. Nature doesn't do dualities. What we're talking about, say, could be charge and discharge, the two infinite states where one seeks equilibrium, right? Charge and discharge. You're charging up, discharging. That's an easier way to think about it. Not super relevant here, but I do like to keep it real when we're talking about nonsense things. Right, so this is what he was talking about. He did a test. The true magnetic field, top and bottom toroids, we live in the middle of this, right? And he ran a compass over this to show the field lines. What he also saw, surprisingly, was if you do this, it matches what you expect from a bar magnet perfectly. Doesn't mean that's what the fields are doing. There's no flip ring and a bar magnet, etc. However, if you didn't know any of that and you used a compass, you would never be able to tell. Hence why everyone thinks the Earth is a bar magnet and compares it to it constantly. Not the case at all, okay? So this is where we take what he did and we can extend it to what we're talking about. So we now know it's a double toroidal field with a, this ecliptic plane in the middle. We all kind of assume that. This will be confirming it. The thing that we're going to take and apply, though, and go on our own here is that inversion zone. There's at the middle, at the ecliptic here, there should be some sort of polarity switching effect, right? Because that's what we found out with the magnets and bowl magnets and metal, and why would it be any different here? So let's continue. So keeping how true magnetic fields work with stacked bowl magnets, and that they create, both a null zone and expulsion zone, and an inversion zone where the polarity flips, we can then assume that, say, this can be a facet of the geometry of toroids and all toroidal geometry that, between the course of it breathing in or breathing out or charging and discharging, the actual motion that where it goes up and down, that motion causes these lines of force and the whole, vector diagram of the expanding and contracting toroid to invert at the middle. It literally creates an inversion zone at the middle. In this case, it could be similar to like creating the tropics, because this inversion zone is going to create the lines that would form the tropics. If I put it over the Gleason's map, for sure. I think if I do this, then yep, have it expanding outward, and it happens to line up with just the tropic zones. I think this is a geometric property of toroidal geometry, that it happens like this every time. So let's try a different toroid, see if that works, see if this torus works. There's the green one. So yeah, this one and its fluid motion of charging and discharging seems to make the same indications of the tropic zone. You see these inversion zones in the middle where it flips on back on itself and kind of expands outward, curving in an arc. Yeah, that right there is the inversion part. And if we think about how that would look, here's the toroid from all positions. Then we can see it in all of these spots, right? This is the inversion zone, clearly another inversion tropic zone. Right over here is when the forces reach in and, you know, reach in and invert, essentially. Just like from the primer fields when he said the polarity shifts. So we'll keep that in mind for what we're going to look at next. And to tie it in, we're going to rely on our friend Lindsay, Flat Earth Philosophy, Tomb of Illumination, who has been talking about this model since I think I became a flat earther, but it hasn't actually clicked with me that he has been talking about all the principles that I have come to accept. So we're going to use his explanation here, and as it was with me, we're going to use that as the final linchpin to tie it all together to see exactly what's happening. So we're going to give a brief explanation of one of his videos here as he goes through it, and then we're going to tie it in.
So at night we see the back of the sun, the Milky Way, and science calls it Sagittarius A. Okay, so you can assume it's up there. That's one aspect. There's one aspect of the magnet. Break it down, you can see it here, because we're led to believe the sun is in the tropical gap in the ecliptic plane right there. And then you can break it down again, which science doesn't tell you, that we have an image of the night sky in the southern hemisphere, just like they have one in the northern hemisphere. It's broken down again. So there's a Milky Way there, and there's a Milky Way there. Then, if you're in that one hemisphere, you break it down again, because we all see the universe around us from within our arc of horizon. It's flat with a 180 degree arc of horizon where all the stars, all the celestial bodies are shown to us perpendicular off that arc, from that arc, making us the centre of the universe because we are 90 degrees to zenith. This is how we do celestial navigation, okay? So, let's go back now. That sun is projected here. We see a sun, supposedly there, only due to the light spectrum. Because back here, pure plasma cannot be seen anyway. But out here, due to the light spectrum, that's all based on frequencies, we have the sun here in the tropical ecliptic plane. But in reality, we only see one image down here in our personal dome of horizon. And we're getting it off this image here. Because in the southern hemisphere, all the celestial bodies come out from the south. They're mirrored from the north. All the northern stars come out of the centre here. They spin out this way like this. This is basically the magnetic field of the toroidal field. This was classed as the spider web in celestial navigation if you're travelling north in the northern hemisphere. Don't think they have a name for out here. So anyway, there's a meridian. Everyone's on a meridian north to south. They will get their image, their mirrored image of what's going on in this slice of the pie. And this is another thing. Science doesn't tell you that. Slice of the pie, you can consider that as a slice of the pie in the earthly system. That slice is what you're going to get in your arc of horizon. So that turning, that's a full-time turning rotation of the vortex in the northern sky. Celestial.
Right,
you know,
so
photography, nighttime photography, astrophotography, seeing the stars going around. It's the flat plane up here. It gets brought down into the southern field like this. So this forever turning rotation in the middle here is casting an image out south that turns all the way around here. So one rotation in the middle here is one 360 rotation all the way around the perimeter. So at one moment in time, you're only getting a slice out into your arc of horizon if you're in the southern hemisphere, and you're getting that rotation. Because that's turning, you're still getting a full rotation here. Stars drift in, and you see them fade out in star trail photography. They drift in and they fade out. They don't do a full 360, they fade out. Because they're moving out of your arc of horizon west. So he'll have an image like this. This guy around here will have the image turned slightly. This guy will have it more turned. This guy will have it more turned. All reflected from the middle. The northern sky, anti-clockwise, turns like this, but because of this parabolic curve in the Earth's magnetic field out south, that gets swung down and projected into the sky like this. So it's now inverted. You're looking at the backside, but it's still a reflection because it's a picture. It's a picture of that cast into the sky, and we're looking at it now like that. It's not as though there's a picture on this side and a picture on that side. It's the same. That's how this parabolic reflection works, due to the concavity of this field with the dark backdrop of night. Okay?
Just wanted to go over this little diagram a little bit. I know it's a little bit complicated and daunting, because I think the visuals are so important. Let's take a look at what we think this is. So we look over here. This is the whole Earth realm with the inner, inner hemisphere, smaller than the outer, marked by the tropicals, with the inner vortex spiraling, with containing the sources for the sun and the moon coming out of here, projecting the only main rotating star field directly above, and then having this parabolically reflected off to the south as an inverted image in every direction as further out you go. And if we look at what it would look like, would look like something like this, right? We got the double toroid model of inner Earth and outer Earth with the toroidal tropics of creation and that inversion zone, as Lindsay always draws and points out. We have the central inner vortex creating the ether wind spiraling out, coming out of the top. We have it, shooting out to the outers and projecting an inverted image of the celestial heaven in the north. So this is what we think it looks like. Everything in the north, that's where the only rotation is. It's the only source of rotation we've ever been able to measure, detect, and or use in any way practical. And then on the south, you have the inverted image of the north shooting out along everyone's zenith, along each individual man's outer arc of horizon, right? So that's what I think it looks like. And as I was going through this, thinking about it, I just pulled together a quick list of all the things that you kind of have to accept as part of the inner workings of the flat earth engine to sort of understand and accept the next part. So we'll just go through them fairly quickly. Of course, all lasting loyalty to the almighty toroid. Joke. That's because all the globers just say word salad as soon as you start talking about any of this stuff. But you do have to accept an inner vortex of energy, comes out of the north, spirals into the center, creates the ether wind with a preferred direction that inverts in the south. Now that's a lot of words, but those who've studied interferometry know that motion has been detected and measured for, the longest time with the ridiculous degree of absolute certainty. So there is motion. What is moving? Not the Earth, the sky. The sky is moving, hence the ether wind, right? So in order to figure out how this works, you have to know that the inner vortex is causing movement, creating everything, creating the ether wind that is a preferred direction in the north that inverts in the south. So again, the inversion in the south is a very important aspect of everything we're going to be talking about. Next, and no less staggering, all the southern stars are parabolically reflected northern stars and projected out of the inner vortex. So you have to accept that everything in the sky is being projected out from the inner spiral. Kind of already thought that, but now we have to accept it if we're going to argue that the southern stars are parabolic reflections. That only works with them being a projection. If the stars are projected, so are the sun and the moon. Fine, we can deal with that. The other thing we have to now accept is a curved firmament, right? We need the parabolic reflection. We need the curve necessary. It's necessary for it to be curved. So because we also needed the firmament to explain the sun and the sunlight throughout the year with the coffee cup caustic effect wrapping around the firmament, we've already had to accept that one. So not too bad. So the final thing is that all the static stars, so the wandering stars, static stars, sun and moon, are all projected out of the inner spiral and displayed on the firmament to see. So I know these are big ones to accept. However, I think most of us have been teetering around the peripheral of them, at least, if not diving full on into each one of them independently and then maybe not telling your friends. So these are the things about the flat earth system that have to be true for the stars to do what they're doing. What we're going to show next is all the instances in which we've seen the celestial heaven act as a parabolic reflection. There are a couple of videos out there of people doing this. Surprisingly, there's usually one comparison using Ursa Major, a part of the Big Dipper, to compare with a portion of the southern sky, and then showing that that is the only constellation that's inverted. Of course, what would follow is you'd have to map the whole sky. However, based on what Lindsay just said, we'll never be able to do that. If the south is a parabolic reflection of the north, but dependent on an observer's zenith, which has to be absolutely southward facing, that's tough to get. To recreate what a person in the south would see, you need their south bearing zenith, and then you can plug it into Stellarium to get it exactly. Without that, it's tough because of the rolling nature of the cosmic wheel and how it works. We can only get a perspective-induced southern rotation if we already match the perspective southern angle. Does that make sense so far?
If
All right,
if
first
we
we're gonna
applied
look
this
at
this
the other
assumption,
videos
though,
that have surfaced that have been around before this. They all come from about 5 years ago from the same person, and it's all centered around the same observation. But let's just pick through it anyway, just so we can get familiar. So, of course, they ran a similar simulation to what I was doing for a long, long time. This is where I got the idea. I started with what they did and figured out why that wouldn't work, and then had to do what I did. But recording, north and southern facing star rotations is definitely a good place to start. Mirroring them together is an excellent place to go. Right, and when you do that, you happen to see some correlations. So there are celestial symmetry all over the sky. So this is the first one, Ursa Major. In the north sky, it's the stars that we labeled. In the south, it's off this one called Achenar, and it forms this other handle with the lid. And from there, you can find the other symmetry. However, it goes in a direction that's correlative with the radial spin of the celestial gear. So if you remember what flat earth philosophy was talking about and how it spins off to each man's arc of horizon, quickly becomes apparent that the rest of the stars become skewed from that position. So did I miss Pizio try to say something?
yeah, I'm. It's kind of explaining it right now. Keep going.
Oh, you notice that your diagram seems to be exactly exemplified on what I stole from you. Thanks, man.
Thanks, bro. It's awesome that you're looking at this and it's like wow. Yeah, keep going, bro.
In any case, that observation was made, right? So he understands the correlation. We're seeing the significance of it, but it's hard at this point to go any further because they look at all the other things. The spiral arms of the galaxy, the Milky Way, always lines up. So that's another one. When I was doing this for hours and hours and hours, I would just, be mirroring and parabolically shifting and doing right to left, left to right, up to bottom, back to front, etc. What I would find is the Milky Way correlates with its other arm a ridiculous amount of time in the sky. Like when it's 180 degrees on opposing sides of a ball, it still manages to correlate. It's weird. It's one of the first signs that there's some sort of symmetry that I was not seeing, right? So that's why I kept looking. He noticed it too. So the clusters is what he called it. The clusters match the clusters. The density matches the density, and the.
All right, so wouldn't this, because part of the sky is like symmetrical backwards one way, and part of the sky with that same motion is not symmetrical, wouldn't that insinuate that like there's within the star field, like the stars have their own layers relative to one another? So like they have altitude comparable to each other.
Well, the
they're not all perfectly on a flat plane like up there either.
Well, they kind of are though. They move like a web, right? They never change distance from each other. The spatially relationship has never changed, as far as I know.
Some of them,
they say
right?
so.
But like, well, I'm looking at your video and it's showing like the Milky Way always lines up and blue star clusters always line up, and some of these constellations line up. But there's others where it's like one side to the other doesn't seem like completely linear.
Yep.
So that's what I'm saying. Like the ones that like aren't completely linear, you would presume that has something to do with a combination of like your angle compared with your position latitudinally and like the altitude of those stars relative to the other ones. Because like the ancient depictions of the cosmos, when they mapped all this stuff out and they had like the astrolabe and they had like the Antikythera mechanism, right? They believed that there was like different layers to the sky. So like you got like the moon, and then you got I think Mercury, and then Venus, and then the Sun, and then Mars, Jupiter,
Yeah.
Saturn, Uranus, and Neptune, and then the background stars.
Yeah, no, I think they're in different layers, but I think the background stars are all in the same layer. And I think that when you start looking for like symmetry, the axis of like rotational comparison is what you have to keep watching out for. I think I'll get into it, but like it's what Lindsay said first was that it rotates around and then it itself also turns, which is what like threw me out because that when you try to track that, it's like okay, that's impossible to track like the personally rotating second cogwheel as it goes around. But there's easier ways to figure it out, and I definitely sorted through it. So we'll see. Besides, this isn't my video. This is the one that's been on the internet for 5 years that everyone's seen before.
Okay.
You haven't seen it?
I'm not. I mean, this is like you narrating on here, so no, I haven't seen your video.
Yeah, that's a good point. I didn't even let him talk. I just took his stuff and talked over it. But like, it's just music, and it pretty much just does symmetry stuff. So I mean, he pointed out that one Big Dipper correlation, and I think everyone's heard that. But there's more. The non-density matches the non-density. So he noticed something was wrong. He made the one correlation, put out the video, hoped others would pick it up, I think. Right? So that's a good one. There's another rendition, I think, of this observation from the same channel. Let's look at that one. So it goes a little bit more in depth here and shows you how to do it, right? He uses image software that is able to reverse images, which is important. And he shows you the time, date, GPS locations, long lat, etc. So this is where I started. I took all this data, I went to do what they did, and I tried to find what I thought they missed. That's what happened. So they show you how to do this. They pick out the stars, the same stars, again, and they show you that they can mirror it, and then it gets reflected. And again, this has been out for a good long while. There's a third video where he demonstrates the theory in real life, and let's go look at that one now. So No Fanfare did a lot of work on this, and this is the model that he built in his house in reality to show that, you know, the parabolic reflection would go reverse direction, would show the same order, would process them in the required way.
1, 2, 3, clap.
And he did a lot of work to set this up in proof of concept, right? To show what it would pass in front of, to show what it would look like. And that's enough for me to see that, you know, conceptually, that works. That must be it, right? To actually factor in all the other variables and perception based and the parabolic reflection and the symmetry of the sky, that's a lot tougher. But to say that the south can be, you know, reflected of the north and show more or less in the same spot that we see them and show more or less the same correlative skewing of known constellations is now like a solid research fact. So that's very important, and we thank No Fanfare for all his work. So let's just show you real quick what I was doing when I was in Stellarium capturing these. So I'd pick a point. All right, this is a location right on the equator. I'll go over the significance of that later, but this is what I found. I'm looking at 1 south, you know, 10, 899. I'm looking at 1 west, 10, 33, 70. Then I'd look north in the north, south in the south, then flip the coordinates and do the same. For this one, I would probably look north. I'd find a time that it lines up. I'd make sure of this time, and I'd reset it back to this time back when I do the southern one. So let's see, let's freeze the time. We start recording. We'd start it going, 1, 2, 3 clicks, let it go. That's not 3 clicks, that's 3 clicks. And I'd record from this section. Now, once I let it do a complete circle, I'd stop it. I'd reset it to the time that it was. And then I would go to the opposing coordinate set on the opposing side. So I'd go date and location. I'd flip this back to the northern or wherever the equivalent was. And I'd flip my orientation for my recording on the opposing pole, and I'd line it up just like this, super close, very on point, very precise, very precise. Back it up to the 102 frame of field that I was working with for everything. 102. There we go. See? So now I know what I'm looking at. I get ready to record. I hit 1, 2, 3. 1, 2, 3, 4 maybe. Let's do 1, 2, 3. And then I record from exactly the same time onward. So I'd mark it here, and then I sync them up, and then I'd record. I'd get 1 full cycle. I'd stop recording, I'd go to video software, and I'd overlay it, mirror it left to right, do front and back, you know, all sorts of correlations to see what I could do. But that was how I recorded the images in case anyone wants to try. So this is the first one that I did, which I just copied what they did. I found what they were looking at. I correlated it to the stars. I was able to find the other stars. I marked them correspondingly. I did the process that I just went over, and then I played it out like this. Unfortunately, I turned off the Milky Way at this point. I wasn't quite sure what I was looking for, and I thought that it was adding complexity to the thing I was looking for. I was very wrong, but this is the one without the Milky Way. We'll go into that later. So overlaid it, transparent, right to left. Here we go. So this is exactly what you would see looking at opposing horizons from that point. Eerie to think that, you know, everything has an antipode and a counter, and that you can, if you're looking north and looking south, you're going to see different versions of the same thing. The rest of the stars circling do seem to have correlation, but it's so frustratingly close, but not quite, right? Close, but not quite all around, which is very frustrating. You have, you know, clusters lining up, 2 and 2, 3 and 3, things like that. But if you notice, like this would be antipodal to this. If you notice where they crossed, that's relevant. So if we're looking
did you do
at
this
like
analysis
right
at
here,
the equator
these two
on
are
Stellarium?
perfect. These two will pass each other. These three less.
Is
a
it
little
more
bit less, a
proportional at
little
the
bit less.
equator? Oh, okay.
It absolutely is, right? That's why would you assume that would be the case?
Linearity would increase with proximity to the equator because that's the inflection point. So the rotation is going to be proportional to the distance from the inflection point of the linearity of the relationship between north and south.
My man. How'd you pick exactly the equator as the inflection point?
I would think that the equator would be the outer rim of the star field.
But to me, it ended up being like the exact midpoint of the toroidal like flex zone, where there's a flip zone where you put two bullet magnets on top, and that, since it rides the magnetic field and it's all about field, then that's why I was assuming that that would have an inversion effect to it.
So like the outer ring of the star field donut up top would like intersect with the like center inversion ring of the toroid around the center.
Yep, and right here I'm pointing out that there's like inner rings and outer rings, and that's when they coincide, and that the inner rings are less skewed, and the more out you go, the more skewed you get. Dude, call it. And that's important.
It makes
so
sense,
look,
bro.
Cross. Down there,
the
cross.
Field,
Come on, concave.
for reference.
And I know I saw those. Those are very misleading and got me into trouble.
Dude, we're like 2 months deep now. We're 2 months deep now since I told Alan and Toby, like, bro, the more I learn about this stuff, the more it just makes sense and it's perfectly intuitive. You don't even need to like go read about it. You just like intuition it, and then you find out it matches what you already thought.
We say that, but then you see my theory and you finish it for me, and that confirms it. That's fucking cool. That's great. Picking up the finer points of it, like, okay, well, if it was infected and skewed, where would it be less skewed? So I didn't figure that out yet, but here. And the cross. So that means that this little area is where it's lined up the best. Outer here, lined up noticeably worse. Well, out here, much worse, almost too worse to notice. So the skew applies from the point of correlation, right? And it gets worse the further away from it you go. So that's what I learned from the first one. And I thought that I was in trouble, and I almost gave up.
I'm glad you didn't give up, because you wouldn't have had this video to like fill in that. Dude, that was a curiosity I had anyway about the like the outer ring of the star field reaching to the equator. Now that you're like showing it to me on here and saying that at the equator, like the linearity maximizes, then that makes perfect sense.
I still didn't know that, so I'm still just doing like this correlation. But now that I got the whole star field and the Milky Way is like the key. It's ridiculous. Just find
so this would mean that you're seeing the same stars, but like stretched proportionally to like your respective relationship from the equator and from the center,
and like a different luminosity. All of them are much dimmer somehow, so you get like a different brightness and a different shape, and they're like, dude, that's a whole new star. Like,
so there's like a prime meridian. So in addition to the linearity, there's also a prime meridian. So like you go to the equator and you maximize linearity, but then you wait for the prime meridian line to go over top of you, and that's the true like maximum zenith.
Well, your southern face-ring zenith is what it needs, because when you go in the south, everything's bearing off that south-facing zenith, and if you don't have that, then nothing lines up. And the sooner you lose it, the quicker it lines up. Like,
dude, so like the prime meridian line, like when it hits the equator, it splits and like matches up the other way. So like it like comes back around full circle to itself too.
Yeah. Yep. So let's see. This is just a couple I think the same comparison. Just rolling with the music. Literally, I just stared at this stuff for 8 hours without figuring out like what I was looking at. But just like it's something. What? It's like, but then I figured out like how far away you go, what the radial rings would show. I put on like the equatorial grid. I put on like every option I could think of, and finally I was
Is there a prime constellation for like that lines up with the prime meridian line in the sky?
What's the equatorial constellation?
I'm not actually sure. It's not Draco, is it?
It's Orion.
Orion. Okay, Orion's belt.
Yeah, I didn't figure that until right now. This is the one that I did Orion. Then I was like, oh, another Orion on the other side? No way.
So if there was a solar convergence event in which the sun passed through Orion's belt at the same time that they were both lined up as your zenith on the equinox at the equator, you'd be in like the perfect center of the universal epicycle. Sun and moon.
Oh, look, there's a southern.
Well, I guess it wouldn't really matter. The sun is like the main axis of rotation for everything else, but yeah.
So when you do the equatorial ones, I focused east to west horizon, so you can see Orion coming up. So I changed it up a little bit. North and south wouldn't show you, but then again, look, east and west. Guess what lines up all the time? Oh, Milky Way. I gotta figure out what Lindsay was really saying about the Milky Way. It sounded too fantastical for me, but now I'm like, wait, I got it. You see that? What is that right there? Is that? Come on.
The Milky Way lines up at the equator.
2 Orions, dude. 2 everything. It's an antipodal everything. To actually map every one would be crazy, because I put on the zodiac and there's like 17 versions of constellations in the first place. So people have been drawing lines all over the sky, connecting all sorts of shit since the beginning of time. So they don't mean anything to me. I'm not going to try and match their constellations, just where the stars are. And you can see the clusters coming in and out right now too, even to me. The other way is like which way it gets flipped is part of the parabolic reflection, and that's kind of tricky. Like right here, it's coming in. I put on both celestial equators, and I can see that they're not lined up. When I'm exactly at west on the equator, why wouldn't they be lined up? That one with Orion, though, looking the other way. And then you can finally like sort of put in perspective the correlations that I am making and that have been made, and point that we're really trying to make here, right? So we're in Stellarium and we're looking around. We see, normally this is what we see. Everyone looks for Orion. Everyone can see that's the belt, and then we can see the rest of the thing taking shape. What we're really showing you is that, let's remove the ground, that if we want to look at Orion, then for every constellation, everything that you see, there's an antipode in the sky going in the opposite direction. So this is above the eastern horizon. What I'm going to do is turn to the west. Oh look, above the western horizon, what's this? Another Orion's belt and exactly the same correlation with the same shape. A little bit dimmer. That's odd. This one looks a lot like the other one because it's not as skewed, because it's right on the equator, right? The location that we're using here is 0 south, 0 west, as close to the equator as I can be. So that's what I'm looking at. So when you're saying that the same constellation appears in opposing ends of the same sky, obviously that can't happen for a globe, so we'll just name it something different and no one will notice. That's what I think happened. If we look at other constellations, let's say the Big Dipper, right? Ursa Major. Obviously I'm in the north right now, I shouldn't be able to see it, but let's just pretend that I can see it, because if it's in the north but below the northern horizon, a little bit to the right, now I would expect to see it if I look south, above the horizon to the left, right? Inverted. Let's see if that's right. South, up, above the horizon to the left. Holy cow, there it is, just like we would thought it would. So when things start to move,
real quick, sorry, I hate to keep interrupting, bro. One thing I love, bro, is that like I remember, I think there was one point when you first like heard about this, like you were like protesting to it because you didn't think it made sense, and then like you went and looked at it and figured it out, and like it makes perfect sense to you now.
Mirrored reflection? No, it always made sense. I just didn't want to talk about it because it felt silly and I couldn't defend it. You mean like your vortex thing?
Yeah, like the toroidal geometry and the like the parabolic reflection of like the symmetry at the equator and all this stuff, like the whole model.
Yeah, no, I kind of like, so it fits into my model. The reflection I didn't want to imbibe because I was like iffy on it, right? I didn't quite know until I started doing this, and then I was like, well, if that's true, then like that confirms actually 7 of my other theories, like black sun model, sun is a projection, source projection, like if ether, wind, center vortex, all that would have to be true for this to work. So that's why I got excited. I'm like, either everything I know is right and it's a parabolic reflection, or I'm all wrong. So that's why I was like, okay, I'm going to go full boat into this then because it already coincides with everything else that I have come to accept.
Hey, just for context, what are the 3 stars that mimic the Orion's belt?
I don't
Good
know.
question.
I didn't look at them. I can go find them for you, but like they're all named nonsense stars. Like the ones I turned off all the labels to do it because it was just text. So I'll find them for you.
Okay.
I still have.
Surely they
Stellarium
know
open.
about this. Like, surely this is known about.
Honestly, it's one of those things that I'd be like, "Oh yeah, you know the truth. You gonna tell people? Go ahead."
Dude, you gotta be able to hook this up to AI and have AI map it out with a neural network or a machine learning.
It'll
algorithm.
never be a map like you want, dude. I tried for like 8 hours to get like the whole thing. I figured I could just triumphantly do it. It never works. It never works because it's a product of perspective. It only lines up for so long, for so many rings, and then it just naturally gets skewed.
Well, yeah, but what I'm saying is if you could map out at least one constellation on each side and one in the middle, so Orion in the middle, and then like the Big Dipper and its inverse on the other side, a machine learning algorithm could go using those as center points of reference and build everything else off of that via comparison and ratios.
Maybe that's something to consider. Looking at this though and doing this, I was trying to figure out how they backwards engineered the celestial sphere. Because if they used azimuth angles to add them up, they would have had to have all their southward facing zeniths and known about this exact thing to do it, and then just like burn the evidence. Tell the opposing action
hold
is
on.
happening.
This is exactly what they would have done. They would have just done the azimuthal equidistant transpolar conversion like they do for AE map to globe, but done that on the sky. So if you just take the celestial sphere and do an AE conversion on that, you should have the map, and you could even invert the southern part to like fix it if it needed to be.
But the southern part gets inverted for each person. Like the way that Lindsay describes it, it's a ever expanding outward spiral according to the golden ratio that turns in on itself. It's so elegant, but the way it's like a fractal of itself, and that's what you expect in the toroidal geometry. When I was playing those toroids back and forth and they would come in, go out, all those vectors of force lines would like do exactly the same thing and then invert. I watched it for so long before I was like, do toroids invert? I feel like if this was something, Witsit would have said it by now, would have put it in a rap, I would have heard it 7 times. No. But I'm like, maybe he just doesn't know. I'll go on a little.
Bro, what you would do is you would take you would do a full alignment. You would let the simulation run, like, forward into the future or back in the past. It can calculate, what the stars should look like for millions and billions of years or whatever, right? You would go back into the past or into the future and find like whenever like a full alignment of every layer. So like the moon, Mercury, Venus, the sun, Mars, Jupiter, Saturn, Uranus, and Neptune, and then the background stars with the prime meridian on the equinox at the equator, and at the point in time in which everything lined up, you would use that as the point in time that you do the azimuthal equidistant conversion of the celestial sphere into the AE map and use that as the sky projection. That would be what the star field would look like.
Well, let's set that up and get it done. I could use some help, buddy.
I got all these stars modeled out. I got it diagrammed out, and I have them in a Blender. If you guys need any assistance and you want my opinion, let me know, okay?
Those star maps that you put are all wrong. I can't use any of those.
Well, my invitation's out there. If you like my input or opinion, just let me know.
I'm actually jaded because that one map is what got me in trouble in the first place when I didn't understand what it meant when I did the first presentation. That's why I'm like, get it away. But I appreciate you, man. Actuality, all over the sky. But nobody notices because it skews from the point of correlation. So if you don't have a corresponding exactly southward facing perspective to compare it to, it'll never match up. No one will ever know. Brilliant. Staggering. Amazing. And as we go through the final sort of summary, let's keep in mind that this whole explanation is a response to the Glober answer for, yes, we know exactly what's doing in the sky. We know exactly where the stars are. We know exactly what they're made of. We know they're this many hundreds of light years away, reflecting light from each other all the way back past the sun's light and through an expanse of infinite nothing that you can definitely see because light travels forever and never attenuates, etc. Right? So that's their explanation. And when we say, well, no, it's not, they go, well, what's the answer to everything else that explains? Okay, right. So we can explain sort of where we think it all comes from and why it is, but again, it's going to sound outlandish to them, so it's best to preface it with the understanding that this is my alternative to their answer of how they think they know how everything works, right? So entirely hypothetical based on solid nuggets of, different understanding, but at that level of verification, I think, right? We'll never be able to verify any of the stuff they say. So let's treat this explanation by me roughly the same. All right, and so to tie the whole concept together, the whole principle together, let's start with everything that I presented before was accurate. Personal azimuthal grid of observability, globe model being derived backwards engineered from elevation angles to Polaris, the backwards construction of the sky based on, Cartesian azimuthal coordinates to a cylindrical with infinite ceiling, all of that still very valid. The only thing that I would be amending in the final sort of comprehensive package is the position of the southern stars, which would be extremely pertinent to the Southern Cross example, right? When you can see the Southern Cross from 3 different opposing points in the south. Had to go through a lot to try to explain it with a southern star rotation up top, but because now we know the truth, there's only one rotation in the north that gets mirrored out to the south. When the question comes up is how do these 3 people in the south look in different directions see the same thing? It's a lot easier and a lot harder all at once, right? Because the explanation is, well, they're all seeing their mirrored reflection of the antipode of the northern part at their southern zenith, right? However, they're not going to understand what the heck that means. They think bottom of the feet, you see a ball. That's the way it works. But way more complicated in that than in reality, and way more elegant than that. So the end result would be, the final truth of how this all works isn't going to convince a glober. It's not for them, I don't think. We can still try to use the basics to convince them that it makes sense on both models, i.e. azimuthal grid of observability with the moving observer-based latitude-dependent azimuthal grid moving around with the observer. That's still totally valid. That's exactly how it works. Perfectly represents where each observer sees each star. Totally fine. It is, like before it was part of the explanation, and this would be the final part. However, the final part, understanding everything, means that you would have to accept, a outward emanating toroidal vortex coming from the north that puts in motion everything in the sky, that causes a measurable ether drift as a source of rotation all around the earth with interferometry and things like that, which has a inversing effect past the equator in the south for all things measured that we can confirm. You can see how it starts to become a lot to understand where the actual southern star is. So the best practice, I think, would be to keep where we were before with the personal azimuthal grid and just explaining how it works, how we see what we see, and try to avoid explaining where the actual star is. Because once that comes up, it's a little bit harder to explain all the truth, and to understand it, you have to understand, 7 other tiers of truth, which a glober will just never touch. So again, the truth probably isn't for them. I set this path in motion because I wanted to know what really happened and how it really worked. And one of the saddening things when you're trying to do it and realizing it, and you're like, oh, I get it, I figured out, but I'll never be able to convince anyone. That's kind of what you think. But I mean, I think I'll be able to convince some truthers who have some of the pieces already, but probably not a glober. What you can do, though, is, like I said, attack the argument, lateral-based dependency. I'll never be able to convince anyone, but I can convince Pizio. I just said I may be able to convince another truther who has some of the truth. Oh, it already happened, though, so that was cool. The better approach would be to attack the foundation of the argument. So don't answer the specific questions about this star's where. It's, well, when the globe model was backwards engineered from observations to the celestial heavens, this is how that works, right? So that's probably what I'll be doing. Anyway, thank you all for coming on this journey. Let me know how you feel about all the things I've presented, and if you absolutely disagree and you think I'm retarded, definitely let me know.
Still got the paint.
Let me know what you think I'm wrong on. Let me know how you think it works. The problem is, for all this to work, we have to have an understanding of each of the phenomenon. This model explains, non-physical sun, elevation angles to Polaris, sun angles on the equinox in Australia, sun angles all over the Earth, eclipses. So if you have an explanation that explains all these things differently without a personal azimuthal grid or a non-physical sun that we see in a personal spot, definitely let me know. Definitely, please put it in the comments. Send me an email. The problem is I've never heard of an opposing set of explanations that would make any sense. So this is what I think is happening. There you go. That's it, man. Now we can open Stellarium. play around. What do you think, Dave?
Fantastic. I'm in storage. Sorry.
Yeah, you can tell immediately. What the hell? I've been afraid to close Stellarium because like it takes so long to mark this stuff, and I have no idea how to save it.
Oh, you better save it first.
I hit every save button I could find. I don't think it'll do anything because every time I close it, I have to redo it. Let's do this on this screen. Oh boy. Does anyone have questions? Anyone disagree?
I was just gonna say I caught the last bit of that on YouTube, and it was epic. I mean, as a person that's just searching for truth and wanting to hear truth, I enjoyed it, and I appreciate all the hard work you guys are doing. This is epic.
I appreciate all your positive comments every time you're around, uplifting everyone around you, JT. Everything's great. You guys rock. Thanks, bud.
Yo, do you have a schematic for how to build those wheels?
Yep.
Oh, do you really?
Yeah, I put it in the. I mean, I talked about the process right before I did it, right? So I have it recorded, and then I have it laid out, and then I have it like, yeah. I've been in Stellarium a long time now.
What wheels?
I don't know. Someone, Alan's cat in the chat was asking if anyone had a plan for making those geared wheel set.
Yeah. Oh, I don't know what that means then. I thought he meant like the wheels of a star overlap standing out.
No. You know you probably showed it earlier. It's the center gear, and then it has like 6 gears around it.
Yeah,
that.
Someone made that and sent it to Lindsay. Do we
Yeah,
need to make it?
Oh.
No, he was asking if you had a schematic for it.
It's all made out of paper and matchsticks, dude. That dude's a freaking genius. I couldn't recreate that.
Hey,
it even
Shane
spins.
St. Pierre.
Yo.
Also, if your reflection with like a proportionality to the north versus the south is true, also what you'd be able to do is on the same day and point in time that I said before, is it should just be a map of whatever the north of the equator is. That should be the only true circle of stars.
It is.
Yeah.
That's what I know.
So whatever the north looks like, that's your star map. There you go.
Well, that's the secondary thing. Like instead of getting outward facing zenith angles from perpetuity and matching them, overlaying from every perspective from all 12% of the people that live in the south would have been really hard. What if they just really studied the north and then figured out the parabolic inversion formula and fucking infinitely extended it outward, like put it back in? That would be how I would do it, I think.
To create the apparent
well, no, the southern thing, because if they need a southern half of a celestial sphere, if they put a sphere around the globe and they need the bottom half, they would just map it by parabolically reflecting it mathematically outward to the bottom to get what it would look like.
Yeah, that's what I'm saying. It would be shouldn't it be very similar to an azimuthal equidistant conversion?
Yeah, but
or inversion.
I don't know how to accommodate the skew because it's like elongated and then increasing, so it's not linear. It's like parabolic. Oh, right. Squared. So you just...
Does your perspective of the constellations at your particular zenith change dependent upon your altitude, like at the ground versus like 100 kilometers up in like Blue Origin or something?
That's a good idea. I honestly have no idea. I guess I should test it with Stellarium, but this is the only way I'd be able to do it. So like this is the...
If Stellarium's accurate on that part.
I found it accurate on everything so far. I'm looking for something that it's not. I keep asking everybody because it's all I use. And if it's something wrong, I'm going to stop.
You'd have to collect like high altitude star footage, which there's not a lot of because they don't typically point at the stars when they're high up.
So that's the other thing, guys. Like if the stars are coming out of the center, then two things would be true. Like you wouldn't be able to see them the higher you go up. and if you went to the moon and had to lie about it, you'd both tell a different lie at the same time if you didn't rehearse it. Like, oh, whoops.
Oh, yeah. Coincidentally, we were just talking about that earlier.
Right, so
disappearing at altitude.
Right, when they go up for the high altitude balloons, all of a sudden there's no stars. And you're like, what? Why? I should be brighter, unless they're coming from underneath. Like they're not really up there. They never were.
Yeah. GG.
Like if you look at north and you're like, oh, look at the Big Dipper is right there, and you're like, you know what? If I look south to over here on the lower right, I'll see another Big Dipper. You're like, yeah, fucking crazy. Oh wait, But what's this over here, though? Oh, interesting.
Hey Shane, is there no way to get a whole bunch of flat earthers from all over the plane to record on a particular day? I know the weather would have to play nice, but like caught red-handed, did this, because everything is conceptual. Like we understand it, we get it, we believe in it. Globers don't. But if you had a video, you're like, look, boom, look at this angle, and this is where I am. Would they just say nah to it if we did that work?
Yeah, probably. Dude, they're gonna say nah to this whole thing because different. They're
You could
different.
just find public camera sources that are pointing at the sky and just find out where they are and just plug in their like GPS coordinates. You know what I'm saying? Because there's public cameras that look at the sky. You could just look up a whole list of them and do it with those.
Yeah, for sure. And stuff that's like, you could even start looking back any date, because the stars repeat annually, and it's so frustrating because you want to find that nail in the coffin and get it to where this thing's busted so wide open that it's just game over, which it has been game over for a while, but we're the few, and the many brainwashed, the globers and the brainwashed are actually the many, and I just want to help them out.
All right.
Yeah, well, I mean, I feel like even a lot of flat earthers are at the point where they don't believe in satellites and they don't have a good answer for the southern star rotation.
Yeah, exactly. They don't, and they'll even laugh at you with your explanation, but not like have. Well, how do you work? I have no idea, but I know yours is dumb. Great, thanks.
Yeah, dude, and I was listening to Stationary Saturday earlier, and it's like this upward rising, rotating Earth, blah 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 stuff is almost like a poison, or that whole thing needs to get shut down because Dale and then William on the level, they're both buying into it. They have their followers, and it's like that's not the truth at all. But I don't know how to stop that either.
How do you stop them? I don't think you can.
Well, I just think the truth is the only thing. I couldn't get on. I couldn't get a mic because I was about to talk on there, but I didn't get to say anything.
You didn't get to calm them down.
I can jump in and ask a question about the presentation.
Delion.
What's up, brother? That was sick. That's awesome. That brings me back to when we were talking about the mirroring of the stars in the south.
I was thinking about you. Like, oh, he's here. Nice.
Yeah, all I knew was that made intuitive sense, but that's as far as I could go with it. And then you put it all together. This is awesome. I'll have to watch that again. But I'm thinking about okay, so first it's the southern stars aren't. You don't need crepuscular and anti-crepuscular rays to explain why there's a southern point around which stars rotate.
Right.
Now we're saying it's a mirrored, phenomenon.
Right. So the cause and effect thing can now be changed. When I was asking Lindsay, do you think that what I asked him was do you think that they're rotating a different direction because of perspective, or because he just thinks everything is because it's parabolically reflected?
Yeah. Okay.
I mean, it makes simple sense to say that you're looking at the motion, but there is no extension of the northern field into the south for it to do that anyway. So yeah, I have to amend that.
Yeah. Yeah, and I think it makes more intuitive sense what Lindsay is saying there, because I think the crepuscular and anti-crepuscular is great proof for the parabolic visual space in my mind. That's demonstrating that. But why you have a southern star rotation around a center point, right? This I thought always needed some kind of mirroring. But my question is, if it's mirrored out to the south, then do I say that there's an infinite number of southern star poles, like southern rotations, or are there a set number of them?
There are as many as there are latitude, right? Because it's latitude dependent, no matter what. So there's one for latitude, 69. Just like I said with Polaris, it's the same in the south, but the inverse. But I've always believed that. Because
I have an alternate model. Once Shane's we're done talking about this one, I could show my model real quick, and you guys can check out how the stars work on that one, the southern stars.
Nah.
This is for flat Earth, by the way. There's no concave, all flat Earth. If anyone's interested.
I think I have to run the poles and then put the equatorial grid on so we can see that circumpolar stars are what killed the last one.
I
Want me
guess.
to do it right now or what?
Nah.
All right.
Yeah, I just have one more thought on this. So if I'm thinking in terms of like displacement longitudinally, so like, you know, around the Earth, right? So you're Africa or South America or whatever, and so you're changing your position longitudinally, like not much. Let's just say you're going a little bit east to west or whatever. Would you not? I'm trying to think. There's now like an objective mirrored southern star rotation point. It's almost like literally a mirror. You're looking at a mirror of the northern stars. So like as you were to move east to west, you should be changing your angle towards one of those star point rotation points.
East and west are a circle, don't forget. So you're going exactly the same amount distance from the pole laterally. Right?
Yes, but and the whole time you're going to see a directly south point around which the stars are rotating.
Yeah. Yeah.
Okay, so that's no matter where you are in the southern hemisphere, you know, around the world, you're always going to see that direct southern facing point of rotation or
but only south.
So but only what?
Only directly southward facing. Like, so if you take like a screenshot of it southwest thing, it'll be like weird, right? Because it only appears in the south.
Right. Okay. So no matter where you are, so that makes me think if it's a mirroring effect, I'm trying to figure out how it could be that there's always going to be a perfectly south facing star point rotation.
Because
you know, I'm still trying to wrap my head around it.
Flat Earth philosophy said that it's all based on the meridian. You have a meridian for your man's arc of horizon, meaning that every southern arc of horizon has an absolute southern, like you have a meridian to the north, and that determines it. So I mean, it makes sense to me that it would have to, like you say, everyone has their own pole, and they do, but everyone has the same latitude dependent pole. Oh shit. No. Okay. Chairs wrapped around the mic cord. We're good. Everyone has the same pole because it's latitude dependent. Everyone at that latitude can see it. The only difference would change if you change latitude. Same thing in the north, right? The circumpolar stars, though, right? Like that's what I didn't understand in the last one, that everyone sees them in the south. So that would be weird if they're seeing the same thing 1,000, 2,000, 10,000 miles across.
I got a 5-minute video in Stellarium explaining exactly what stars we see at all parts of the world. Ready to go.
That sounds like a pretty good one.
It's 5 minutes long. I recorded it myself. It'll give you actually in this video I'm not presenting a model either. I'm just showing you what stars we see using Stellarium. It could put things in perspective.
That's like northern stars and southern stars, and which one's visible and which one sinks and which season it is. Eric Dubay nails that and puts it all down. That's useful, but how about we find some antipodal stars? Antipodal constellations. Dude, I took so many of these. I'm looking through my folder now. There's just so many. Here, let's do this one. Oh, PLC is broken. This one right here. So yeah, that Leon, like, I was afraid to incorporate this because I didn't know if I could, if it was, first of all, if it was right, if it was real, and then how I could explain it, and then how it would affect other things. And it turns out it's the only way that it works, and it fits absolutely in with all my other components. And actually, it has to be this way, or the rest don't work.
Yeah, and the fact that Lindsay's had sort of the nuts and bolts of it kind of hashed out. Like when I first was introduced to Flat Earth, I was like, all right, I need a model. So I go to 24/7 Flat Earth Discord on like the chat, and I'm like, anybody can tell me what the Flat Earth model looks like? And I just got derailed and just laughed out of the chat. This guy's got modelitis. And that like brought me to you guys. I eventually found, better channels or whatever to talk about this stuff. And then somebody actually, I was in 24/7 chat that somebody directed me to. It wasn't Tomb of Illumination at that time, but so I just watched some of his videos. Yeah, right, Flat Earth Philosophy. Watched some of his videos, and he was talking about how the sun is a projection, and then when you see the Milky Way in the night sky, you're actually seeing the sun in a nest. The nest being in the center of the toroid, and I'm just like my mind blew, my heart exploded. I was just like, yes, okay, I got my model.
Did you
and
did you catch he was here the other day, like yesterday? I was asking.
Yeah,
Oh,
I
okay.
did. I did not. I didn't realize he was gonna be there. That was that's cool. Was that recorded?
Yeah. It was specifically so I could ask him about this though before I put forth my freaking ideas, right? And like, because he had the whole model, and when I first came, they directed me here, and I watched all the videos, and I went, yeah, I get it. It's that means that it's well. No, I have no fucking idea what I just watched. Hold on, like, what the hell is going on? Like, and the way he speaks, it's like, here's a question. Well, here's a literal answer. Here's half of a symbolic answer. I'm gonna bring you to a quick allegory. We're gonna go half literal real quick. I'm gonna tell you something else. Then I'm gonna bring it back to symbology. Then I'm gonna go to the Bible, and you're like, listen, I think I have like one of the reference books that you use. Could you narrow your responses?
Yeah, man. I liked it in the first moment I heard him talking on a video. You know, he's like kind of like a closet genius, obviously, but like I don't know. He's doing his own thing. He's not really trying to make it make sense to the audience. He's just like passionate about it.
You don't like it, then it's not for you. Fuck off. That's his mentality. I'm like, oh my god, I like him.
Yeah, exactly. It's like he's just recording for himself, but that is a good teaching method, because then, you know, as long as you get it, the people listening will try to pick it up, and they will.
Not necessarily, man. He needs to give his presentations to a live audience of people like us, so we can ask questions, and then other people will be like, oh. If he gets by himself, he just goes off, and then he loses everyone. I think at the end, he's the only one. Like, what happened here?
Yeah. It's like your brain has to be a sponge, because he's gonna give you, like, in one video, like a crap ton to try to think about, and yeah.
Oh, and by the way, join my Patreon with all the true answers. I'll tell you how they can map the whole sky, but I'm gonna need 100 Patreon subs.
Nice. Oh yeah, that's right.
I don't know, man. This is what I was doing in Stellarium forever. I'm gonna find other ones. I think there's an easy Southern Cross one that I haven't marked down, and then once you get like 2 more, the antipodal relationship will just be like symmetrical. You can look up and just see reversals all around. I think that's my determination. I'm pretty sure we can do all of them, but like, it's just correlation where they are, and then a reflected placement. So we're not looking for like the reverse Ursa Major as I did there, because that's close to the equator. We're looking for like the star placement and formation, regardless of what lines other people drew on them. Because for real, if you go on the zodiac thing, you can choose like 73 different types of zodiac, and you're like, oh, so what we drew lines on makes no difference. It's all there. Okay, all right, fine.
Is it helpful for you to try to imagine like what the stars are in reality at the center of the vortex?
No.
And like how they are being projected out?
How they are being projected. So I don't know what they are, right? We don't know. Yeah, how they're being projected out is.
Yeah.
Did you see my Black Sun video? The presentation I did on
yeah, I think I watched that one a ways back. That was recorded a while ago, right?
Yeah, because that's how I think it works, and that fits in exactly, right? They're all coming out of the center, as is the sun and the moon, all the luminaries. Turns out everything in the sky, as well as being projected out of the center and coming from the center of creation, is personal to you. Everything in the sky is there for you and you alone. A ray from the sun that touches your feet at a lake doesn't go to your friend's feet or anyone else. You can't see the one that goes to his feet. You have to assume that he sees his own sun ray too. Same with the moon, same with the stars. Everything in the sky is personal to you. It's such a crazy thing to think about, but it's verifiable, and everyone kind of knows it, and we just kind of deal with it. Like, it's just a weird thing to think about. So when the Bible references, you know, the time in the sky, then every human has their own personal timepiece they can view at any time from any point on the world. What do you guys think? It's kind of crazy. Is Alan still here?
Yo, what up, G?
Oh, what's up?
Dude, great presentation, man. Great presentation, just soaking it in.
Yeah, you sound
Watching
terrible.
the stars, watching the stars rotate. Yeah, I'm just marinating.
Marinating.
Yeah.
So how about this? Like when I look up at the stars, or I'm looking at your screen there, but you know, it would appear that some stars are closer, some stars are further away, right? But can we say now that nope, there's no difference in their there's nothing like that happening. It's
Yeah.
just sort of a projection onto a screen, more like
Yeah.
that.
I mean, like, so they're arguing that actually that star is a burning ball of gas of hydrogen, helium, and iron a bajillion miles away in a vacuum of infinite nothing that's in its third stage of burning hydrogen before it erupts into a supernova that expands outward. And you're like, no, that's a light in the sky, and that's a light in the sky projected from somewhere else on the sky. Like, if you, that's so not any of that. But what it really is, dude, I think it still has significance, right? Like the flickering, the nature of it, the you know, the beauty when you look at it through a camera, what it actually is still beautiful, but it's not up there. Like if you go high enough, like with a 60,000 foot balloon, and all the stars disappear. They're not up there to go to. They're down here for you to see.
Hmm.
I think it means it's like more, it's more mysterious. They're like, oh, they're actually things we can go to and see and look at. And it's like, no, they're not. They're personal to you. They infinitely refract if you go too far south. I mean, they never change either.
That's an interesting way to look at it. They infinitely refract the further south you go.
Yeah. And that's back to Lindsay's model. Oh, that's what I meant to show. Because his, I had to cut up his piece so much because he'll be like, gold, nugget, Jesus reference, back to paraphernalia, like male is female. I'm like, oh my God, could you stick to the.
Wow, he's like slamming his blue marker on the fucking thing.
It's so good though. He has like all the answers. Let's see. Yeah, where's my Lindsay one? He describes like exactly the problem that I faced, and I like didn't even. I went right by it when I first heard him. Hey, Lindsay.
This is basically the magnetic field of the toroidal field.
That's what he said.
This was classed as the spider web in celestial navigation if you're travelling north in the northern hemisphere.
Maybe not.
That gets swung down and projected into the sky like this.
See the meridians that he drew over here? These lines? That's what he's saying. That it based on this meridian is where it orients the whole southern thing, and then it, you know, curves west inward to itself with the outward edges of the toroidal field as it recedes and goes inward, and then it kind of perpetually goes all the way around. The other thing he talks about is this EMF thing. He's sure that the equator has like the place of least electrical charge, which would make sense if the field from the north and the south kind of dips in and goes out. Would also make sense if the geometric toroidal inversion zone happens right there, where like, oh, the charge has to go negative because it goes the other way real quick, and it just reverses polarity. That's the only time I've ever seen that.
The issue you're gonna have. Sorry, the issue you're going to have bringing this up to Globers, like I said, I'm just trying to be of assistance to everyone here. The issue bringing up to Globers will reaffirm, perhaps incorrectly, that you see that north, that there is that vortex tunnel going in. They're going to claim that there's two real one of those in existence, one over the north and one over the south.
I'd like to argue a Glober who thinks there's a southward-facing vortexual spiral creating an opposing ether wind out the south. No, but I hear what you're saying. They think that that's equal and not a infinitely refracting image of it for sure. Honestly, this probably wouldn't be for Globers. We can just argue the backwards derivation of the elevation angle to Polaris, and then, you know.
In that setup where if there's two, then we could create, you see the other image you draw with the curved lines and the little thing in the center spinning?
Yeah.
Then you would have equidistant of those lines from the center towards any point of the Earth, and it'll be an equal like a slice. Yeah, but that's what the Glober's gonna say. I'm pretty trying to, you know, get down with the Glober arguments, specifically with modeling as well. So anything I could, if I could help you guys, let me know.
Well, let me say this, Shane, real quick, and because you had this in your presentation, you're saying, this is probably not the argument for globers. Let me go ahead and say there is no argument for an anti-flat earther. So, I mean, that's just unanimous. There's no argument for an anti-flat earther. They're never,
That's a good point.
But I was a glober, okay? And this is exactly what I needed to become a flat earther. It was Lindsay's model and understanding stars, at least in principle, that there could be an explanation. That's what brought me completely over. It was Austin's debates and like the logical fallacies. I was like, okay, literally one whole foot is in flat earth realm now. But then it was Lindsay's sort of demonstration of a magnetic toroidal kind of construct that was like, okay, I can let go of the globe with much more confidence. So I would say this presentation you have here, in layman's terms and everything, is exactly for globers. I wouldn't hold back whatsoever.
Well, I stand corrected, dude. Jeez, you're right. I didn't think people like you existed.
Yeah, man, dude, globers are normal people. Anti-flat earthers are not normal people.
That's a very good point. Thanks for reminding me.
Yeah, right on.
You're well said.
It's like we spend a lot of time with them, so it's tough to. You're right. I should definitely keep them separate. The average glober, yeah, definitely.
All right. Stay here.
Dude, there's another one that Lindsay has. Like he starts off with Southern. What does he say? Southern astrophotography proves flat Earth. You're like, what? And he starts off with saying like, oh, you can't actually take a slice of the South and watch it and do this. Like, okay, here it is. I think it's on my BitChute because I added stuff to it. Let's see. Why don't you play? It's just the beginning because it's the. I wish I watched it first and I understood what it meant. Because he pretty much said, hey, don't ever try to get Solarium star footage of all the southern rotation because it won't work when you mirror it. There we go.
Fine, so we'll run over that, okay? I'll discover what I've written again. Everyone has just one arc of horizon.
Now
the only you can get circular rotation.
There we go.
On a ball, it's tricky. You can't.
There we go.
Put your camera this way.
He said this is how he found out.
Basically, put a kink from where you are.
Like this, the story about how he found out about this is crazy because he figured out that the northern was the only rotation and he saw a parabolic reflection while in the south. How do you look up at the sky and go, you know what that looks like? A parabolically reflected northern rotation that I've never seen before. Yeah, that makes sense. Like, what?
In the alignment.
But he says you can't do it.
Like
so that little diagram is what I need.
You say you're up here. So from north to there, you put a kink in the line. That view, you're never going to get the centralized rotation, the central point. Dead north, you'll get a nice circular rotation out in the southern hemisphere. As soon as you move your camera this way and start trail those rolling stars,
tapers.
You cannot overlay it onto here because you're not in a dead straight line from there to there. You've put a kink in it and stretched it out. So
it's such a bomb that he dropped right there.
Trying to prove a point by doing that the Earth's not a ball. It's tricky. You can't.
Thanks, Lindsay. Appreciate the effort. That's excellent advice. I tried anyway. But you see his diagrams over here? These like fractal geometric things. He's not just doodling. Like this is a neutral equator tropical zone. This is an outwardly expanding fractal. Here's a golden ratio retracting, ever increasing corresponding fractal. Like what? The way that he draws it is crazy, but his explanation is spot on. Like he takes you to like this little point and you're like, what the hell are you looking at? And then you're like, oh, that's what I thought, but I called it, this, and that's how I envisioned it, but I called it this. And he's got this ever expanding outward, southern rotation, always paired up with a direct southern meridian. So as soon as you deviate east or west of that one meridian, the whole star field recording would shift and warp. So I didn't understand that until I saw it happening, right? I was like, why won't it just line up all the way all the time?
Horizon. So he would.
So I don't know if you guys got more questions or if you want to look at Stellarium or look at Concave's idea. What do you guys want? Andrew, haven't heard from you.
No, this has been good, man.
I'm listening.
I'm here. I'm just kind of listening in the background.
Well.
Sorry, I forgot we had two Andrews. I do want to hear from both of you.
Oh shit, there is. Oops, I'm sorry.
Is it something that Lindsay says that if you go up in elevation, the stars will kind of disappear? Is that, or did you kind of derive that idea?
I said that, right? Because high altitude balloon footage from certain of them, some of them have stars, some of them don't. Some of them have like no stars or less stars. You know, like there's definitely an effect of altitude. The higher you go, the dimmer they get, or what have you. And if what we're saying is true, then they would also be in like splayed positions if you change altitude greatly, wouldn't they? Since your lateral movement and vertical movement changes their positions, the higher you go, the closer to the reflected projection you are. So I don't know what it would look like. I don't know what it should look like.
Yo, I have an interesting perspective. We're gonna look at what Lindsay's diagrams are doing. Basically, I have it in Blender. Check this out. Want to look?
Are you talking about Lindsay Sharma?
Yeah,
Sharman?
Lindsay El Tomb of Illumination.
Well, she's on YouTube and Rockfin. I know this. She did a lot of meditation and stuff with crystals, and I'm not sure if you know her. She lives in Colorado.
Y'all see my seen my screen?
Yeah, what are we looking at, dude?
So, in my worldview, just from my perspective, I mean, I could be wrong here. Me thinking Earth is concave. What in my worldview, this is what Lindsay's seeing right here. This is the AE map. These are the diagrams. This is your central point of emanation here. I mean, in my world, it's inside the middle of the celestial sphere. In his diagrams, but also looking overhead, you've got the sun and everything spinning around, and obviously and this is not to scale, but Antarctica is the edge of your world. Check this out. This might blow some of y'all's minds. This is actually what's happening here. This is what's actually happening. This is a concave Earth 3D model. And if you were so happen to put a camera right inside of the Earth in the middle of Antarctica and look up, this is what you see. And looking at this and letting it digest, a lot of things start making sense in how we think what's going on. In the concave Earth model, the sun is it's
Nah.
here. From an overhead view, we've all seen that flat Earth animation. We think with the sun, when it comes towards the north, it spirals up higher, and then when it comes down towards the south, towards the Tropic of Capricorn, it spirals down lower. This is a unique view, and in this view, from the north, if we're just factoring in the north, there is that's his diagram. That's toroid right there. Okay. But in this one here, there's actually two of them, two true ones in this model.
Yeah, well, you don't have.
North,
I don't know how you can have two, man.
One's here in the south.
But that's never been measured or found,
That's basically that, and you've got rings of spherical pressure gradients going towards the center.
The thing though, concave
that's
is.
Really all. That's all I wanted to show is this. This blew my mind when I saw it for the first time.
But that's not based in reality, though, right? Because there's only ever one source of rotation in the sky that's been measured through like years and years of interferometry, and it's been repeatedly measured. So we know with like a reasonable degree of certainty there's no other mysterious, unmeasured, undetectable secondary rotation anywhere on Earth.
Yeah, that's basically what it looks like when you're looking down from this angle. You're seeing the overhead of one of the toroids. That's what it looks to. Yeah, there's one rotation going east to west. But if you were so to go down the rabbit hole a little bit deeper,
Toby, what do you think, man?
This is something that we would get. So I actually have a glass here with the glass spheres refracted. Look at that.
Other Andrew.
So like an observer down here. I mean, this is all fucked up, but
Other Andrew, Toby. What do you guys think?
appreciate for looking.
Just real quick about the concave thing. I mean, you know that I'm somebody that's entertained the idea of two poles more so than maybe some of the other people. But the problem is the continents arrangement, and that people walking upside down antipodal to each other. There's no force enough to do that. It doesn't make any sense. In the reverse engineered concept of the concave, it's just like the ball, and it's going to work out to seem like it might be plausible if you accept that the continents have to be in a different area that don't know them to be, and that people are walking upside down relative to each other, which we know can't be true. So it's a nice inverse idea of the ball model that's reverse engineered to begin with, but there's too many other things that do not work with it to make it actually reality.
Do you know what's
Whereas
really
I think
good with
Shane's
this?
got a pretty good take here on what actually might be going on. You should consider it instead of just focusing on the concave. But that's interesting. It is interesting the way it works out that way.
The good thing about this model is that it like when Witsit was like, we need something that is how to show how they backwards engineered the globe, and you're like, oh well, actually it matches the globe perfectly because you don't have to do any of the nonsense stuff that they don't have to do, right? Like it just solves itself easily. Oh, it is where you see it. So simple explanation.
This is it's a diagram.
We had 60 people on Rumble. Wow.
In this model.
Did you want to address anything I just said about the people walking upside down relative to each other? Or
Nah, let's not turn it into a concave thing. Let's finish this off, then we can go concave.
I wouldn't really be able to address it, but just the way the gravity works is it would be. I think the best answer where I'm at right now is it's electrostatic, and the electrostatic part happens. Between
Yeah.
these rings. So we're like in one of these rings, and so when you go up into space, there are regions of zero gravity. So you're like in here in these regions where so look at this right here. So where are we right now? Okay.
Well, you know what? Wait, we're not going to go into that. I just
why don't
wanted
we
to address
that?
Yeah. Dave
Wait,
tried to
Shane's
ask
trying to
some
do his
questions.
thing right now. He asked if we could just do the concave later. Is that cool, bro?
Okay, well, Shane finished this thing, and I had my time.
No, he just asked right now. Hold on, wait. This is not your presentation, bro. Hold on. Shane's asking that we do the concave thing later, bro. You're kind of butting in.
Don't call me bro. Don't call me bro. Thank you very much. I'm done.
Hey, I was trying to give you the time of day, okay?
You probably shouldn't.
Yeah,
do that.
whatever.
Who
That's it's too bad because your attitude really just like
Dude, how
counts
do
you
I?
out.
How do I
stream is over,
differentiate-
correct?
How do I differentiate Andrew from Clearview Andrew?
Just say Clearview. Don't call me Andrew.
No, Clearview Andrew it is. Clearview when Andrew's around, I guess, because his name
I'm not even looking really, so I'm doing something else. I'm just kind of listening.
Oh.
So you say Andrew, I expect it's Andrew because that's his name on his tag.
Okay, all right.
Although he is an electrician just like me, so it is kind of, got to be careful. I only really, I think, interact with Andrew in here and ADL anyways. Everyone else just calls me Clearview.
Right. That's because I don't like calling people silly things. Especially people I talk to a lot. Well, I mean, we can try and end it out.
I think that you should, if I were gonna be, if I were you, I would try to do like, because for the critics maybe, try to get the names of the stars that are lining up on both sides, and so that maybe they could even. Oh, you did? Okay.
Put them in chat.
Like,
Yeah,
like
there's
the Orion or whatever.
Like here's the 3 that I found in Orion. They're named fucking 23 Akil, Sigma, whatever the fuck that is. But I copied all the stellarium information you can get from it, so that should be helpful.
Okay. And then I would say maybe slow down the video so you could see the the alignment's coming up a little bit more specifically. Maybe zoom in if you could. I mean, I'm just saying anything you that would be like a topper to what you've already done. If I could
Yeah.
suggest.
So when you zoom in, a bunch more stars pop up, so that complicates rather than helps. But like the way that the alignment works is you can't like you can see it coming, but only if you know what you're looking for. Like you can stare at that all day with no markers at a place that you've lived in that you've known your whole life, and you still won't be. Like for me, I wasn't able to tell because they all kind of blur together. So I need markers. If you look at like a spot, say, and watch it rotate, then you can see what lines up with that spot. Right, if you watch it the whole time, it rotates. But if you're just looking, like I ended up just staring for a good many hours. Right, while talking to you guys.
Also, it'd be good to have like ones that are well known, right? If you're looking at Orion's belt, there's a few, right?
Well, that one is well known, right? That's why it's so
even
helpful.
even the ones that aren't even actually at those conversion points, but just ones that are well known. Watching their rotation in relation to what's going on, right? Just it makes it a lot easier for those who like maybe only can notice like the end of the Big Dipper, or maybe like the 3 stars in Orion's belt, and everything else is just a scramble.
Yeah, that's kind of where I was at, man. That's kind of where I was at. And even then, I couldn't really find Orion's belt. Like I was like, oh wait.
I don't think it'd be very hard to recreate like a simulation of this with a disco ball light type thing and a mirror.
Well,
like you could almost show how this works.
No Fanfare did it, right? I showed a bit of it. He built a fucking model. He acrylic it, cut it out, put it in the dome, got a light, did a parabolic reflection, gave it a power source, sent it around the rotation. That's how I was like, oh well, he did that part, so I don't have to. That's proof of concept for how
that's a good example of it.
Yeah.
Yeah, conceptually, you could kind of just think of it as you have the one rotation above, and you just invoke all the perspective stuff that you explained very eloquently, Shane. And then you use the exact same perspective to do a counter rotation. But the thing that you need to take into account is that, just to put it simply, not saying that this is literally what's happened, but you could think of kind of like a curved mirror around the edges of the Earth. And so as you walk out in towards that curved mirror, you see that rotation rise as you go out or down in latitude or out away from the center. And so then you see your own rotation that is directly relative to the pole behind you, the northern center pole of the actual rotation. So yeah, it's all just like essentially like a curve mirror. That's a curve. That's a representation of what's behind you.
Yeah. Yeah. An infinite or like an ever expanding outward. What do you call it? Outward spiral, like according to the golden ratio. What's interesting is like if you take a left hand or a north and a south version and you flip them both, like so your north is mirrored, your south is mirrored. What do you think would happen? You think the same thing would repeat, right? The overlay would just go in backwards. It's not the case. It's weird. Like you can flip.
So based on what central point? The southern central point? Is that what you mean?
Yeah. So
what is the southern central point in there? What's it called?
So now it's just a
southern area. Because they say there's no star there or some bullshit.
Well, they say there's Sigma Octantis there, but then you can't see it, and then it's definitely dim. But don't worry, it's totally there. But no, it's just a parabolically reflected Polaris, man.
So then you probably don't see the same thing if we're basing it on the star trails that we see, right?
Well, you see a warped, reflected version of the same thing. That's why I know, like, if you didn't line it up, it'd be tough to see. That's why I was so amazed by Lindsay. He's like, "Yeah, no, I knew it. I figured this out." So you just from in the south, you noticed that half of your star trail was missing, and you deduced that was due to a missing parabolic reflection. Like, I think you said, "No, I've been to the north and I've seen it before," and I was like, oh, "Okay, that makes little sense, but is kind of still impressive that you were like, well, mine looks fishy compared to that." But just like this stuff, like the Milky Way arm always gives you crazy symmetry. Whenever it comes back around, everything else aligns. Depending where the Milky Way is, like all these stars line up right here. Every single one. You can't tell which one's south or which one's north from this transparency thing I did. That's probably kind of difficult. Right? Only with the motion can you see which one is which, but they all fucking line up right there.
Hey Shane, did you already post or show a screenshot or anything of your list of things you have to accept for this case, or you just name them?
I think I showed it in the video, but I literally wrote them out. So let me get it. So I was like, oh boy, I have to do how many things? All of them? Let me just write them down.
Show me your
Yeah, that'd be cool to
presuppositions.
see.
These
You
are
know,
now
it's
your
nice. It's nice to have a terms and conditions, man. Just lay it out up front.
By the way, you will now accept all of these flat Earth premises.
Yeah.
But like talking to like this crew, I think we all accept all those anyway.
Yep.
Because we figured them out. Let's see. Yeah, I wrote down. I wrote down this, Dave. Because Toby was like, which effect causes which? And I was like, good question. Let's break them out. Oh, that's a lot of space. Dude, you have to admit ever dying loyalty to the almighty toroid, and you can only use toroidal inflection jokes, and you must say toroid 3 times a day. It's funny because my computer's been on so long, VLC crashed, and I didn't want to close it because all my shit's saved, but now I can close it. Putting stuff in Windows Media. Jesus. Well, that'll do it for us here. Thanks everyone for coming and tuning in. Thanks everyone on Rumble and Rockfin. We'll probably be back with more streams, but if you have any questions, definitely send me an email and come on down to the Aether Cosmology Discord. The link in the description.
Yo, we got toroidal terms and conditions.